User-defined primitives. Now let's take some time to talk about a new and interesting topic called user-defined primitives, otherwise known as UDPs. Now, I'm guessing that you've never come across this topic, am I right? Well, that's okay. We'll discuss it now and make you familiar with UDPs. Now, first, we'll see how these primitives came into existence. Verilog provides us a standard set of primitives, such as and, or, nor, and not, as a part of the language. We usually call them built-in primitives. However, designers rarely like to use their own custom-built primitives when developing a design. Verilog provides us the ability to define user-defined primitives. Now, this is how these UDPs came into existence. These primitives are self-contained and do not instantiate other modules or primitives. UDPs are instantiated exactly like gate-level primitives. Now we'll see some of the basics of UDPs. We'll start with parts of UDP definition. A UDP definition does not depend on a module definition, and thus appears outside of a module definition. A UDP definition can also be in a separate text file, and we can have only one output, and may have one or more inputs in a UDP. Now let's see the discrete parts of a basic UDP definition in pseudo-syntax form. Similar to modules, even the UDPs start with UDP name and terminal list. In the UDP name and terminal list, we shall start a UDP definition with the keyword primitive. Then primitive name, output terminal, and input terminals are specified. We can have only one output. Next, we'll see the terminal declarations. Now, as usual, we declare terminals as output or input in the terminal declaration section. For a sequential UDP, the output terminal is declared as a reg. Next off, we have UDP initialization. For sequential UDPs, there is an optional initial statement that initializes the output terminal of the UDP. Next, we have UDP state table. The UDP state table is the most important part of the UDP. It begins with the keyword table and ends with the keyword end table. The table defines how the output will be computed from the inputs and current state. The table is modeled as a lookup table, and the table entries resemble entries in a logic truth table. Primitive definition is completed with the keyword end primitive. This is how we define the UDPs. Now, we have a few rules for UDPs, so let's take a look at those, shall we? UDPs can take only scalar input terminal, that is only 1 bit. Multiple input terminals are permitted. UDPs can have only one scalar output terminal, that is 1 bit. The output terminal must always appear first in the terminal list. Multiple output terminals are not allowed. In the declaration section, the output terminal is declared with the keyword output. Since sequential UDPs store state, the output terminal must also be declared as a reg. The inputs are declared with the keyword input. The state in a sequential UDP can be initialized with an initial statement. This statement is optional. A 1-bit value is assigned to the output, which is declared as reg. The state table entries can contain values 0, 1, or x. UDPs do not handle z values. Z values passed to a UDP are treated as x values. UDPs are defined at the same level as modules. UDPs cannot be defined inside modules. They can be instantiated only inside modules. UDPs are instantiated exactly like gate primitives. And lastly, UDPs do not support in-out ports. Now let's see the types of UDPs. We have two. They are combinational and sequential. Combinational UDPs are defined where the output is solely determined by a logical combination of the inputs. The best example we can give for this combinational UDP is a 4-to-1 multiplexer. Sequential UDPs take the value of the current inputs and the current output to determine the value of the next output. The value of the output is also the internal state of the UDP. The best examples we can give for this sequential UDPs are latches and flip-flops. Both combinational and sequential UDPs must follow the UDP rules which we just discussed. Now we'll discuss the details of combinational and sequential UDPs in upcoming lessons. Now so far we've seen the basics of UDPs, and now we shall go to the next tutorial where we'll talk about combinational and sequential UDPs.